Okay, our new chapter 3 will be about functions. So you will see some things you've used in Algebra 1 before, and we will just add on to some of those concepts to give you everything you wanted to know about functions. Looking at the 6 graphs that are here, you will see a line, normal, happens to be oblique. You see segments, I guess we would call those. You should recognize this as an absolute value graph. If not, we will be covering those this year. A curve. So that is definitely not linear, but the majority of them we're going to be working with will be linear. Here is an exponential. Starts low, goes high, and then you can get your wave graphs, up and down, increasing, decreasing, different values as we go. So just a look as to what kind of situations we're going to deal with. But in the first section, we're going to be nice comfort zone. Slope, y-intercept, properties of linear functions, what is constant increase, decrease, how do you interpret graphs, what is a piecewise linear graph. So without any, let's check and see. We could say again which these were. But we're going to hit all of them at some point during this lesson. Here is their values in case your equations, in case you're interested. And now onward to our linear functions. You should have down that a function, we've been using this, is a pairing in which each x value is paired with exactly one y value. We learned something like you look at the x's. If they repeat, make sure they repeat with the same number. If they don't repeat, you're good to go no matter what the y's are. Then we should also have a working knowledge of domain as a set of all x values of the function. Range is your set of y values. Mapping is a new phrase. We sort of said what was f of x notation and mapping notation when we're talking about arrow notation. Arrow and mapping were the same kind. So that word shows up again here. Mapping shows how each member of the domain is paired with a member of the range. So if we just looked at the sets, and let's start with the pink one, -3 is paired with 1. And when we do that, we think, okay, it goes together. 0 is paired with 2, and 2 is paired with 4. There's no other possible combinations. We like to call that a one-to-one function. Every x has exactly one y. Let's look at the second one in orange. -1 is paired with 5, 1 is paired with 3, and 4 is paired with 5. So you're seeing two different x values being paired with the same y value. Yes, that is a function, but it's not one-to-one. Everybody doesn't have their own. And the last one, when we look at it, 5 is paired with 6, -3 is paired with 0, -3 is paired with 6, and 1 is paired with 1. This is not a function, because if you remember the definition again, every x has to be paired with exactly one y, and we've got that -3 that is paired with a 6, and then it's paired with a 0. So if you have a line going from one x value, and then you have another line going from that same x value to a different y value, you definitely do not have a function. So this is just another way to show those relationships. You might see some pictures, arrangements like this in this chapter. All right. Because we expected you to come from algebra and geometry with some basic concepts, this is an example of lines. Now you'll notice all lines are straight, all lines are linear. But specifically, these are special because the red and the burgundy go up and down vertically. The blue and the green go left to right horizontally. So you should know already what we're looking for. Notice we've got our origin right over here. So start looking based on, here's your origin. Where are you at if you're at the green equation? Not only where are you at, but what type of line is it? You should be able to say, that's the equation y = 1. That whole line, because everywhere on it has a y value of 1. Look at the red one. Count. You should be able to tell me that's x equals 5. A vertical line has a different beginning to it. Then we go back to a horizontal. It's at 3. And then we go back to a vertical. It's also at 3. So you should be able to tell us the equations for any vertical or horizontal line. And that should have come with you from algebra and or geometry. You also have worked in algebra and geometry with our basic linear setup called slope-intercept form. So these would be sloping lines. We also call them oblique. We also call them diagonal. So those would be some other words you could use. So any diagonal line and oblique. Is that other word you probably heard? Slanted, sloping, they already used. Those are all good words. Because unlike the vertical and the horizontal, you don't see that sloping feature on a vertical and horizontal. Now, you should also know these are all linear functions. And we should know some characteristics about those b and m values. So double check. Tell yourself right now, what do you remember? M, everything you can think of about m. And then check. It could be called gradient, slope, or constant increase or decrease. All good names for an m value. Do the same thing with that b, that number that sits by itself at the end of the equation. What are the names? What are the things you have been calling it in those different classes? Did you say y-intercept, initial value, or where the line cuts the y-axis? Those are all key. The y-intercept is b. If we're doing a story problem, we like the phrase initial value. Where are you before you start the situation? That's the y-intercept point. And then where the line cuts the y-axis is another common phrase for the b value. So far so good. We haven't really seen too much that's new. So let's double check we know how to draw a line. This one's going to be your first method you learned, which we just call the XY table method. So here's our equation. It already is in slope-intercept form. You probably first learn to choose 3 values for x. Y3, you learned in geometry, 2 points determine a line. The third one sort of makes sure we have the right combination and everything lines up accurately. So we'll choose 3 values for x. It is totally your choice. I would probably stay with a positive, a negative, and 0, but you can see here I've just chosen 3 positive values. Then you'll calculate those values. So when I put 1 into our original equation up here, y came out to be 1. When I put a 2 in, y came out to be 3. When I put a 3 in, y came out to be 5. Using order of operations, you had to multiply first and then subtract 1. Once you have your 3 points, the next thing you learned was to plot those points. So you can see we went to the right 1, up 1. We went to the right 2, up 3 for the second point. And then we went 3 to the right and 5 up for that third point. Plotting the points. Those are just 3 of the points that are on the line. Then we drew the actual line they fell on. And notice I go a little past the 3 points. Make it go on forever. Put arrows on the end. All our lines in y equals mx plus b form should be that, lines, and not line segments. Last but not least, label that line. Especially as we get more complicated, you might see more than one equation on a graph. So if you label your different lines, you will be able to keep track of which one's which. Okay? So that was your XY table. But you've also learned a second method now. It has something to do with slope. So remember, here's a particular problem. And when we start on this one, we find that y-intercept point. So right here, that would be 0, 1. We found the y-intercept point, and from there we said we went up 2 and we went over 1, as you can see. So rise over run was another way to say it. Change in y over change in x. So you have to come up with one of them and just stick with it. Don't worry about knowing all of them. Pick one and go. Gradient is from business more than slope. We've used slope a lot. and we're going to stick with that, but gradient is a good vocabulary to think about it. Think about a road grader. When it actually sets up the gravel and dirt, it is grading the road because it has to be at a certain slant, certain steepness for drainage, for the agricultural in the area, shoulders of the road, all that kind of stuff. So slope is key. So based on that, you should be able to tell me the slope of any of these segments. Now, if you look at A, line segment A, you could pick the points that are all highlighted in B as nice places to try to figure out what your slope is, because all you need is that rise over run factor. And if we have that rise over run factor, you should be able to tell me what your slope is. So look at all of these, try them, and if you see any that are tougher for you, make sure they're asked about in class. I'm going to go to one in particular. Let's just go to G, line segment G, and start looking at it. I have a nice point right here that intersects axes, but then if you follow it up, there is another one here, and there's another one at the end. They don't all do that. So if they fall in between, and point line F also has that same situation, that looks like it's a nice whole one. Then no, no, on the way down, no, and then yes again. So you would have to go farther out to do your rise over run on both of those. But still, do your math, and you should be good. Also look at the direction of the slant of the line. That's key. Oops, I got all kinds of yellow blob on that one. And then in G, we pulled the answer. Let's pull the answer up. We should have a -2. Or a -3, sorry. -2 on F, -3 on G. But if you can't figure any of them out, make sure you ask when you come to class. So that's just finding the slope. Now, more of them. Maybe these will be the ones we talk about in class. I'll ask you about. So again, look at them and see what issues you might have. Now, remember, there are two parts to the equation. When we say we have y equals mx plus b down here, we have that number in front of x, and we have that, which is known as a slope, and we have that b value, which is known as a y-intercept. So right now we're looking at that number in front of x is always your slope. The number standing by itself on the same side of the equation as that is your y-intercept. And remember, the definition for a y-intercept is the place where your graph crosses the y-axis. So there's our 3, and then we go, we could go in this case down 2 to the left 1, and think about that. If I go down 2, that's a -1, and I go to the left 1, that's a -1. So when we simplify those numbers, we are getting 2 over 1. We could go up 2 over 1, but my graph, you can see, runs out of space. So now, not just the slope is a possibility, but you can tell me the whole equation. So let's just do one of them, and then if you write some of them down, I should be able to ask anybody when we come to class and have a discussion what these equations are in terms of y equals mx plus b. So again, what do? You look for that, where does it cross the y-axis first? And if we're doing number 1 together, I'm seeing it crosses the y-axis right here. Look at your intervals to see, is it counting by 1s, 2s, whatever. And then try to find a whole number point that your line is cutting through when you do rise over run. So if we do this one, I think our other point besides our y-intercept would be this point right here. And so we would do up and over to get it. And so we would be traveling, looking at this one, up 3 and to the right 1. So we should be having a slope of 3, and that y-intercept was 1. So put it in the equation form, and you should have slope-intercept. So we're not just saying we're going to give you the equations. We might give you the graph. You have to be able to find the equation from it. You should be good at that by now. So again, here's some more that we'll probably use in class. Double check. You can identify all of them. What is your y-intercept? What is your slope? And if you have any issues with any of them, bring them up in class, because I will definitely be asking some of your classmates to answer them as well. All right, So you are going to have a couple graphs today, but you're going to be writing more about your not inequalities, your equations that represent your graphs. So bring questions. We'll handle a couple of them in class, but I think for the most part, 3.1 should be a good review section for you.